Glowing star, share the spotlight, your genius ideas could be featured in our upcoming videos. Imagine seeing your suggestions come to life on screen. Prior to starting mechanical excavation, our aim is to excavate with precision at the designated location, adhering to specific dimensions, elevations, and slopes, all while prioritizing safety. This procedure covers all types of excavation works necessary for foundations, trenches, construction of buildings and structures, underground facilities, and laying underground pipes. Our excavation process aligns with approved drawings, GFC/AFC, project specifications, and relevant codes and standards. Abbreviations, GFC/AFC- good for construction/approved for construction. Abbreviations, GFC/AFC- good for construction/approved for construction. ITP inspection and test plan. Responsibilities. Site engineer obtains necessary excavation permits in accordance with safety procedures from concerned authorities. Analyzes drawings and coordinates resources as per the plan. Implements stringent safety measures for the entire project. Ensures the execution of the inspection and test plan, ITP, for all inspections and tests. Maintains meticulous records throughout the procedure. Tools and equipment. 1. Excavator. 2. Dumper and bobcat. 3. Essential hand tools. A. Excavation for structures. 1. Excavations follow site regulations, including excavation and blasting permits. 2. Surveyed lines and dimensions conform to approved drawings, encompassing working space, shuttering, and necessary slopes. 3. Deeper excavations require additional planning, covering dewatering systems, shoring, if needed, access, and safety precautions. 4. Efficient material movement from excavation to the designated dumping area is pre-planned. 5. Adequate shoring and strutting are implemented in sandy soil areas. 6. Dewatering is executed using suitable pumps to manage water inflow during excavation. Dewatering is executed using suitable pumps to manage water inflow during excavation. Trench excavation. Trenches are narrow excavations that are deeper than they are wide. They are often used for laying pipelines, cables, or utilities, and for creating foundations for structures like buildings and retaining walls. Basement excavation. This type involves digging out the space beneath a building to create a basement. It's common in residential, commercial, and industrial construction. Cuts and fills. A cut is the excavation of material from a higher elevation to create a level surface, while a fill is the placement of excavated material to raise the ground level. This is done to prepare a site for construction or to reshape the landscape. Channel excavation. This type involves digging channels or trenches to redirect water, often used in drainage systems, irrigation canals, and water management projects. Dredging. Dredging involves the removal of sediment, debris, and underwater materials from water bodies like rivers, lakes, and harbors to maintain navigation, increase water depth, or reclaim land. Open pit excavation. Commonly used in mining operations, open pit excavation involves the removal of large quantities of earth to access valuable minerals or resources. As the name suggests, it creates an open pit or depression in the ground. Foundation excavation. This type focuses on creating the foundation for structures. It involves digging to reach suitable load-bearing soil or rock layers to support the building's weight. Cavern excavation. Caverns or underground chambers are excavated for various purposes, including storage, shelter, and even as part of infrastructure projects like underground transportation systems. Underwater excavation. When work needs to be done beneath water bodies, specialized equipment and techniques are used to excavate underwater. This is common in underwater construction and salvage operations. Road and highway excavation. This involves clearing and leveling land to create roads, highways, and other transportation infrastructure. Stripping. Stripping involves removing the top layer of soil and vegetation to expose the underlying material. This is often done in mining and large-scale construction projects. Rock excavation. When dealing with rocky terrain, rock excavation techniques are used to break and remove rock layers for construction or mining purposes. It's important to note that each type of excavation requires specific equipment, techniques, and safety measures to ensure the successful completion of the project while minimizing risks to workers and the environment. Seven. Manual or mechanical excavation is conducted to achieve precise dimensions, levels, and a uniformly compacted bottom. 8. Excavation depth shall not exceed the grade in drawings, unless non-suitable material removal is necessary per specifications. 9. Material below the drawings grade is replaced with approved material and compacted thoroughly, with measurements recorded. 10. Sequence planning maximizes excavated material usage for site backfilling. 11. Excavated earth is stacked a safe distance from the excavation or disposed of as indicated. 12. Nearby structures, pipelines, and cables are well supported during excavation. 13. Rock excavation involving drilling and blasting follows the guidance of competent and responsible supervision. 14. Proper side slopes are adopted based on soil nature and excavation depth. 15. Excavations deeper than 1.2 meters must have man entry and be properly barricaded. 16. Preventing water accumulation and unattended excavations is crucial. 17. Some areas like airports and refineries may restrict mechanical excavations. 18. All trenches for pipes ensure appropriate depth and width for joint bedding, haunching, and surrounding. B. Excavation for utilities. 1. Trenches and utility excavations meet required depths, slopes, and working space indicated in drawings. 2. Unsuitable conditions at excavation bottoms are rectified with approved material replacement and compaction. 3. Excavations near existing utility lines or structures ensure safe operation and protection. 4. Utility lines are handled with care to prevent any interference with ongoing operations. Preparing silt trench. 1. Purpose: a silt trench serves as a preliminary step to assess soil conditions and locate utilities more accurately. 2. How it's done: we create a narrow trench alongside the intended excavation area. 2. This trench helps us evaluate soil quality and identify signs of moisture, which can impact stability. Protecting services. 1. Why this matters: essential utility lines like water, gas, and electricity run underground. Essential utility lines like water, gas, and electricity run underground. One. Safeguarding these services is vital to avoid disruptions and ensure safety. 2. Metal detectors. Specialized metal detectors precisely locate utility services. 2. Upon discovery, we clearly mark their positions and implement measures to prevent damage during excavation. Preventing collapse. 1. Importance of stability. Trenches are susceptible to collapsing, posing severe risks. 1. Sturdy support measures are essential to maintain trench stability and worker safety. 2. Methods for stability. Sloping involves creating a stepped trench wall, benching establishes horizontal levels, and shoring reinforces walls with hydraulic jacks or braces. Managing materials. 1. Clear trench edges. Keeping excavated materials at least 1 meter away from trench edges is crucial. 1. This distance prevents accidental falls or materials spilling back into the trench. 2. Monitoring soil conditions. Regularly assess soil condition. 2. Wet or unstable soil increases collapse risk, necessitating constant monitoring and adjustment of safety measures. Safe distances away. 1. Maintaining safe distances. It's not only about keeping materials away, workers should also stay a safe distance from trench edges. 1. This precaution reduces the risk of falls or objects falling into the trench. By incorporating these details, we ensure that the excavation process is not only thorough but also safety-focused, leading to successful project execution. Thanks for watching, Glowing Star, Together Towards Greatness. By collaborating, we're turning good content into great content. Your insights are incredibly valuable to use. Follow /www.techdosengineering.com.